Hello, my name is Elefteriadou, and I'll present a project that has been developing guidelines that agencies can follow to model autonomous and connected vehicles so they can determine their impact on capacity and other traffic operational measures. This project is led by Dr. Mohammed Hadi of Florida International University with collaborators from Georgia Tech, North Carolina State University, and the University of Florida. Transportation analysts have been using various modeling and simulation tools for planning, design, and operational analysis. These tools help us evaluate the highway system, they help us assess alternative scenarios, and the impact of strategies to mitigate congestion. However, what has not been addressed adequately yet is the modeling and simulation of the emerging connected and automated vehicle technologies. For example, what will the capacity of a facility be if there are 20% connected autonomous vehicles on the road? Or should my agency plan to add lanes along this freeway in the next 20 years? Or will having autonomous connected vehicles on the road result in a capacity increase? What percent of connected vehicles should I assume will be on the road in 20 years? Should autonomous connected vehicles operate in exclusive lanes or in mixed traffic? And if they're in their own lane, what's the capacity of such a lane? The challenge is that there is significant uncertainty about these vehicles. We don't know how connected autonomous vehicles will follow one another, how they will change lanes, and how they will accept gaps. We also do not know how human drivers react to the autonomous connected vehicle presence and whether their driving behavior will be different. There's limited information available and just a few data sets. Therefore, it's very difficult for a practitioner to determine what assumptions to use. Without this information, we cannot develop accurate models. And at least for the foreseeable future, we must rely on microsimulation supplemented by limited field data on autonomous connected vehicle operations. So to address this challenge, the research team studied a wealth of resources in the literature and reviewed existing data sets. We examined arterial and freeway applications and focused on mobility and safety impacts. We also met with representatives from state agencies in the Southeast to understand what their main challenges are when attempting to model autonomous connected vehicles. Based on state DOT feedback and a thorough literature review, we developed guidance that practitioners can use to model CAVs. The guidelines discuss pitfalls and challenges and provide recommendations based on the data available to date. We also assembled a few representative case studies to demonstrate various modeling scenarios for CAVs. The research team is now wrapping up the draft final report, and we hope to make this available very soon. We anticipate that agencies can use these guidelines to model CAVs and to help them make decisions as they are developing their long-range plans. We're looking forward to working with you and your agencies to help implement these guidelines, and we're very interested in refining them as better information becomes available. So look for our final report sometime in February 2022, and the research team is looking forward to answering your questions.